When a car reaches a traffic stop, the driver should disconnect the engine power from the transmission. For a manual vehicle, the driver presses the clutch pedal, disengaging the transmission from the engine power, hence letting the engine keep rotating on its own. How about an automatic transmission car? It doesn't have a clutch pedal, so how does it disconnect from engine power at the stop and then later smoothly start moving again when you press the accelerator? The answer involves a clever device called a torque converter. But before we understand how a torque converter works, we first need to understand what torque actually is. Torque is the turning effect of a force around an axis or pivot. In simple terms, while force pushes or pulls something in a straight direction, torque is what makes something twist or rotate. So, what is a torque converter? A torque converter is a fluid-filled device located between the engine and the automatic transmission. Instead of using a solid mechanical connection like a clutch, it uses transmission fluid to transfer rotational energy from the engine to the transmission. Inside the torque converter are three main components: the impeller, the turbine, and the stator. Let's see what each one does. The impeller is connected to the engine, so whenever the engine runs, the impeller rotates. Let's look at the second component of a torque converter, which is the turbine. The turbine is connected to the transmission input shaft. The fluid thrown by the spinning impeller pushes against the turbine blades and causes the turbine to rotate. When the turbine rotates, it transfers power to the transmission. Why doesn't the engine stall? When the car is stopped, the engine is still running, and it continues rotating the impeller. However, the turbine can remain nearly stationary because the fluid rotates with less force due to lower engine power when the vehicle is at a stop. You might ask, why does the engine produce less power at the stop? This is because the throttle is not open enough to let air into the intake manifold. Here is how acceleration works. When you press an accelerator pedal, the car ECU receives signals telling it to open the throttle valve. When you press it hard, the ECU opens the throttle valve widely, allowing in more air into the intake manifold of the engine. The MEF sensor measures the amount of incoming air. It sends the signal back to the ECU, which again releases fuel according to the amount of air. The more the combustion, the more the crankshaft rotates, and the more torque it releases, hence making the impeller rotate faster. When the vehicle is starting from rest, the torque converter can actually multiply torque. This is where the third component becomes important. The stator sits between the turbine and impeller. When the turbine is moving slowly, fluid leaving the turbine would normally flow in a direction that would oppose the impeller. The stator redirects this returning fluid so that it assists the impeller's rotation. This allows the torque converter to produce more torque at the turbine than the engine was initially supplying. As the vehicle accelerates, the turbine begins approaching the speed of the impeller. The difference in speed between them becomes smaller. As a result, the torque multiplication effect decreases. Here is where the lockup clutch comes into action. At cruising speeds, this clutch mechanically connects the engine and transmission. Since the engine's power rotates the torque casing directly, the clutch locks onto this case, hence skipping the torque converter. In simple terms, a torque converter acts as a fluid-based connection between the engine and an automatic transmission. Thank you for watching. Like and subscribe for more informative content like this.